In the past, we've talked about arithmetic sequences, things like 1, 5, 9, 13, where each time some amount is being added or subtracted. Plus 4, plus 4. Okay. In this video, we're going to talk about geometric sequences. Now, geometric sequences are sequences where each number is not the result of addition or subtraction, but multiplication or division. So, for instance, an example of a geometric sequence might be 1, 3, 9, 27, because each time I'm multiplying by 3. The fact that we have a common ratio instead of a common difference means we're talking about a geometric sequence. Common ratio. Another way of thinking about it is this sequence here. If the first term is A, the next term is A times the common ratio. The term after that is A times the common ratio times the common ratio, or times the common ratio squared. The next term is A times the common ratio times the common ratio times the common ratio, or times the common ratio cubed, so on and so forth. We could define them recursively by saying that any term in the sequence is equal to the previous term in the sequence times r, or we can define them explicitly. Any term in the sequence is equal to the first term in the sequence times the ratio to the term number minus 1 power. So recursively means we need to know the previous term to find the next term. So if we want to find the next term, an, we need to know the term right before it, a to the n minus 1, and we need to multiply that by the common ratio. Explicitly, we can find any term in the sequence if we know the first term, and we multiply that by the ratio, the common ratio times the term number minus 1. So here we have a term, a sequence 7, 21, 63, 189. And what's happening each time is we're multiplying by 3. So the recursive formula is whatever term we're looking for, a sub n, is going to be equal to the previous term, a sub n minus 1, times the ratio 3. That's the recursive formula, recognizing that the first term is 7. What about the explicit formula? Well, the explicit formula looks like this. The term we're looking for, a sub n, is equal to the first term, 7, times the common ratio, 3, to the n minus 1 power. So if we're looking for, say, the 10th term in the sequence, a sub 10, that'd be equal to 7 times 3 to the 10 minus 1 power, or 9, which we could solve on our calculators. Furthermore, we can write these explicit formulas as functions. So here's a sequence. Let's say we have 12, 24, 48, 96. Common ratio here obviously is times 2, times 2, times 2. So the explicit formula would be whatever term we're looking for is equal to the first term, which in this case is 6. I forgot to include that. We could do it with 12 too, but we'll do it with 6. 6 times the ratio 2 to the n minus 1 power. Now, if I wanted to rewrite this as a function, something we could graph, I'd say f of x, where f of x is a term number, is equal to 6 times 2 to the x minus 1 power. Now we have a function of this sequence that we could actually graph. Notice really all I'm doing is replacing a and n, a sub n with f of x, and n with x. That's all that happens between the explicit formula and the function. So how do we know if we're dealing with a geometric formula or a arithmetic formula? Well, just look for whether it's a common difference or a common ratio. Remember 1, 4, 7, 10 versus 1, 4, 16, 64. Common difference of plus 3 here. Common ratio of times 4 here. And then let's quickly review the explicit and the recursive formula for this. The recursive formula is simply a sub n is equal to a sub n minus 1 times 4. The explicit is a sub n is equal to 1 times 4 to the n minus 1 power, which we could write as a function, f of x equals 1 times 4 to the x minus 1 power. And that's geometric sequences.